My next guest is Richard Hartmann, Director of Community at Grafana Labs. Richard, it's great to have you on the show.
Thanks for having me.
Just to kind of refresh memories of our viewers, tell us quickly about Grafana Labs. What do you folks do?
We make observability data beautiful. We give you this one single pane of glass without trying to lock the user in, which most others try and lock you into, like buy this product and replace everything else which you have and everything will work, or maybe not. But that doesn't usually work, in particular once you leave those super small companies. Even medium-sized companies are always in some migration. So by not locking anyone in and really truly following this big tent approach, we actually show different data sources, all in the same style, in the same overview, and you can even combine different data sources.
So what open source projects are you leveraging to offer observability to your users and customers?
That list is quite long. From the strategic point of view, it would obviously be Grafana itself. Then you have Prometheus and Cortex. You have Loki. You have Tempo. Those are like the core things, because there you cover the metrics, logs, and traces. There's a variety of others. We have an agent. We have Tanker for actually deploying to Kubernetes. We are compatible with Jaeger, with Influx, with pretty much everything.
If you look at observability, and you mentioned all these projects, and that's what the point I want to drive this is, if you look at observability, not just observability, but if you look at the cloud native landscape in itself, it's crowded, it's busy, there are so many projects. So how do you make it easier for your users, Grafana Labs users, so that they don't have to worry about all these different components that they need for very good visibility of their stack?
So it kind of depends. On the one hand, moving to cloud native is obviously quite the task if you have brownfield deployments. And in reality, you will run a mix for quite some time. And in particular, the larger the companies, the more you will be running this. Of course, legacy is just another word for actually making money, and that's why you need to maintain all of those. So obviously, you need to pick and mix what you want to have, but that's kind of a no answer or non-answer. Of course, the other part of this is, no matter what you actually use for your observability, or even if it's not observability tools, you can still just put all that data into your dashboards and everything. So it really is not a case of us telling others what they need to use. It's more a case of us using and supporting whatever the users need, which I like more from the moral and ethical or philosophical point of view, but also it's good business because it just enables more people to use the same thing.
Can you also talk about the importance or significance of observability monitoring, having a very holistic kind of view of your stack in modern cloud native world, when we are seeing a lot of workloads, especially if you look at Kubernetes, they are going into production, especially because of pandemic. A lot of companies have accelerated their digital transformation and cloud native journey. So the kind of user that were there in the early phase, the people who are early adopters, they were experimenting. Now people are running critical business on top of these technologies. So how important is observability for these users?
Very, very. For the simple reason. The fundamental building blocks of what cloud native is, you see in other fields as well. It just where you have your service boundaries, how you package different types of complexity into different packages to make them manageable, changes with cloud native. But the actual underlying needs of compute and such haven't changed in decades. But for a lot of cloud native stuff, you talk about horizontal scalability. You talk about breaking things down into smaller services, so you can have different teams own those different parts of the service and such. And that means a lot of the complexity which previously was hidden behind the operating system or maybe behind your one process or what have you is now more exposed again. And as usual in this cycle, in these tech cycles, you allow more or different use cases, but you also get new problems with this. And basically, With the older style of monitoring tools, you cannot really make all of this complexity, which is all of a sudden surfaced. You cannot make this grokkable for humans anymore. So at the core, observability is about making complex systems understandable for humans and also for automated systems. And that's really it. This explosion of complexity across several different orthogonal vectors, which happens all at once. In particular, once you uplift a lot of your old services and also introduce new services, and then you run them in parallel. So you have this multiplication. It becomes more and more complex. And being able to get this overview, that's at the core what this is about. And without it, you don't have a chance. So it's a hard requirement to have this.
Can you tell me what exactly is Prometheus?
Prometheus is a time series database, which basically stores values which change over time along with the time. You might have temperature, which just changes over time. That's super common. You might have a counter for requests to a service, and those are time series. And in older systems, you had, 1,000 per service would have been a lot. But now with this explosion in cloud native, you have tens of thousands, hundreds of thousands, millions of them. So Prometheus on the one hand is just a time series database. On the other hand, it is a system which allows you to actually deal with this immense amount of data. So it is highly efficient in operation. It has a query language which allows you to slice and dice your data, your n-dimensional data sets, precisely as you need them. PromQL, that language is called. When you use it for alerting, you use it for dashboarding, you use it for extracting data, you use it for creating new data. And all of this is done through this one language. So you have to learn it one language, yes, but through label matching, you get more or less magic working of data fitting together like Lego pieces. And on the other hand, it's basically vector math. So if you're familiar with large-scale computing systems, weather prediction and such, you don't have this CPU-style computing where you have lots of different instructions and this changes all the time. You have this more like GPUs, which are used for, again, weather simulations or blockchain, where you set a computation and then just toss all data in and you just take all the results out. And by writing queries that way, it doesn't matter if I have 0 or 1 or 10,000 matching data sets. All of them are just computed through at the same time with the same logic, which is immensely powerful once you have a ton of data or a constantly changing set of data. Of course, if you have your containers and they restart every 20 minutes or every hour or every day, you get a lot more churn in your data. Which brings us to the next point of what Prometheus is. It has tons of integrations for service discovery. So if you run Kubernetes, you just point Prometheus at your Kubernetes and Prometheus knows precisely what you run and just starts monitoring it. You can also do file-based, which is super nice if you're currently migrating towards all of this. You can do zone transfer, which is in particular nice if you do this for networking and such, where you usually have everything in DNS zones and you just transfer the whole zone and everything is done and you have integrations with pretty much all the major cloud providers as well. So you run at cloud provider X and you just point it to their endpoint and your Prometheus knows what exists and just goes there and pulls from it or scrapes it.
Can you tell us a bit about what's new in Prometheus? What does the roadmap look like? It's, of course, fully open source. Anybody can go and check, but I want to hear from your perspective.
So a lot of what we did recently was about making it easier to handle or easier to hold with features like top K over time, where previously you say, I want to have the top 5 heavy hitters in traffic or what have you. It doesn't matter, but you say, I want to have the top 5. And then you look back over a week and you don't get 5 results, you get 20 or 1,000. Because at that point in time of every single evaluation, it would take those top 5, which makes sense under a lot of circumstances, but also it's counterintuitive, in particular for new users and for certain use cases. So we have a lot of overtime functions now, or new overtime functions now, in particular top K, where I can just say, give me the top 5 over the last week, and I don't have to filter out all the non-heavy hitters over that time. We have a ton of new service discovery integrations where you can integrate with more clouds and more orchestration layers and such. And yeah, basically this kind of thing. And looking into the future, we'll also have quite a lot of those, where we're trying to make it easier for people to use Prometheus, for the simple reason that we see this. You mentioned this. There is this new wave of adoption of new people coming into the cloud native scene, and they have different requirements. So making it easier for those users to use Prometheus out of the box is one of the main things. For example, officially, we do not recommend that you use an agent system. We do recommend that every single metric endpoint is on its own port with its own path, and you just scrape from that one thing, which makes sense in a purely cloud native setting. But if you are in an enterprise and you talk to the security team about, hey, I want to open these 300 ports and they are not even continuous and they might be open or they might not, they will look at you not in a friendly way. Hiding everything of this behind a single endpoint has downsides. Of course, all of a sudden you're tightly coupling the version of your database with your Linux kernel maybe, which isn't really good from like the truly cloud native perspective. But for a lot of users, it just makes sense. So supporting this kind of thing. The other major part of Prometheus is, or what we are looking at, is certification. Of course, we are to some extent or to large extent a victim of our own success. We are the de facto monitoring standard in cloud native and beyond, which is great, but also comes with a lot of people who like to claim they're fully compatible, but maybe they're not. And on the one hand, to help those projects and those vendors to become compatible, but also to help the users actually make an informed call. Is this and that piece of software which claims to be 100% compatible actually 100% compatible? And if yes, along what axes? Some might only care about the exposition format. Some might care mostly about PromQL. Some might care about the remote read-write integrations. So there's different interpretations of what it means to be compatible to Prometheus. And to make it, again, easier for projects and vendors to implement against a reference test suite. And on the other hand, for users to make an informed decision of who is actually compatible, along which axes, to what extent, that's a focus area for this year.
You were talking about use cases, some new use cases, of course, there's brownfield, there's greenfield. Also, you mentioned because of this pandemic, there is a kind of, accelerated. I'm curious if you have seen any use cases or users which you were like, hey, this is something that we want to talk about, because this is an exciting use case of Prometheus.
The main use of Prometheus is in cloud native, obviously, because that's where we are tightly coupled. We are super tightly coupled to Kubernetes, so that's kind of obvious. But we are also seeing a lot of use in particular in the industrial sector. For a simple reason, a lot of those uses are simply literally the same, and also for more classical IT. And let's walk through first the industrial and then for the traditional IT, of course, and why they're pretty much the same and why it makes sense. So there is an insane amount of knowledge about the world which can be encoded in time series. It might be the temperature of your chocolate extrusion valves, and I'm not joking, like this is an actual thing. It might be vibration of a machine, which is again a real world, or all of those will be real world examples which I know about. The density and the tension on the fabric and on strands while you weave high performance fabrics. Those are things which are really needed for people on those production street in those industrial sectors to make a call about how their thing is performing, how their industrial line is performing. I even know of one thing where they have a port and they unload coal. And just by weighting the conveyor belt, they know how wet that coal is. And if it's too wet, they cannot put it in storage for quality, whatever reasons. So they just stop the ingestion of that coal if it's too wet. All of those things are basically domain subject experts putting a number to whatever they really care about, and then emitting this to a system. More traditional industrial control systems are super expensive, super slow. Even for 2,000 data points pulled every 5 minutes, you're easily in the high 5, sometimes low 6 figures just for that, which is insane. For Prometheus, that's nothing. You can run this on a Raspberry Pi if you want to. So we see insane uptake on this industrial sector, but that also goes to more traditional IT operations. Of course, they are, if you get down to it, they are just industrial sites. They have a genset, they have power distribution, they have HVAC, they have all those things which you have in more classical industrial settings. But once you start taking this data in, you can actually have your full stack visibility. I can have my service visibility from the genset and from the power, from the medium voltage station, all the way to my customer-facing microservice and everything in between, and all of them have the same label sets where it makes sense. So I know if I have more traditional IT, that my microservice running at that site is dependent on this and that genset or this and that sub-distribution for power, to this and that HVAC system. So if all of a sudden my databases get slower for that one microservice and I see the temperature spike in that room, I know what's up. Again, this is not a cloud-native mode of operation, but it is very much a reality for a huge amount of people and a huge amount of operators. And combining all of this and educating those sectors that there is already something which is highly optimized and optimized way beyond their usual needs is something I do a lot. Just try and do this kind of outreach, like talking to industry groups and such, to explain to them how they can leverage those systems.
When we do look at all these new use cases, we're also seeing increasing focus on, of course, security, and sometimes observability and security. There's a lot of overlap that's going on there. How do you look at this? Do you see that these are, complementary? They will remain, adjacent to each other, or over time, because a lot of security-focused projects are also part of CNCF, or over time you will see some consolidation will happen. Of course, there is already some happening, that it will not be two separate things. Because even if you look at security, if you have no visibility into your stack, how will you secure it?
Yeah, no, absolutely. So you have to look at security from a few different angles to fully reply to this question. So first and foremost, security is about preventing things which could, in theory, happen from actually happening. That, in the essence, is what security is. So if you're looking at active security, this might actually be locking down certain things or using TLS and these kinds of things, which I will ignore now. Like, they're super important, but I'll ignore them for the rest of this answer. If you look at this from the perspective of being able to understand what is happening in the system, obviously you have a few tools and systems which are purpose-built for security, but they still emit data which you need to ingest and which you need to make sense of. But also a lot of the things you can just do with your already existing application data. Like if you were to track logins, and you just take the ratio of successful logins versus unsuccessful logins. If you see a huge spike in unsuccessful logins versus the successful ones, that might be one of your authentication backends going bad, but it also might be the case that you are seeing some attack or some cracking, some password enumeration and such. And that is something which you can already do with metrics quite nicely. Because in this point of view, metrics are simply a distilled by domain subject experts, distilled events into counters, into other type of numeric information. The other security relevant thing, and there you get into the absolute core of security, but outside of Prometheus proper, is logs. Logs at cloud native scale allow you to do immense amount of security work, because a lot of the due diligence, a lot of the aftercare after break-in, tracing how an attacker moved through your network and such, is about looking at logs. And you will have tons and tons and tons of logs. So now once you start talking about this data with the same type of label sets between metrics and logs, you can actually also extract all of this from your log data. MTail by Google did this like ages ago, but it was very isolated and just did it for its own. If you look at things like for Grafana Loki, where you have this built in, it's a lot more easier to handle and a lot nicer integrated, because you can just start emitting from, I don't know, this and that type of error. And I just start emitting counters for this and that thing already with all the relevant labels attached to them. Or I just drill into this and that type of error afterwards, or I set my alerts directly on it. But the more you get into actual incidents, analysis or due diligence, the more and more you will be moving away from pure metrics and more towards events, in particular logs.
Can you also talk about the importance of Prometheus as the kind of basis or foundation of cloud native monitoring?
Yes. So at the core, cloud native monitoring is again about containing all of this exploding complexity. And as Prometheus scales so well, and back when Kubernetes was new, was one of the very few, maybe the only one, which scaled as nicely while being as easy to operate, there was kind of a natural lock-in. Like both Kubernetes and Prometheus were developed independently of each other, but as Kubernetes is modeled on Borg, Google's Borg, which is their container orchestration and such, and Prometheus was modeled on Borgmon from how the metrics work and from the pull model. AP-wise, it's more modeled on Monarch, which is also a Google system for monitoring. So you have this in the underlying philosophy. You have a very tight coupling already. Of course, Kubernetes and Prometheus share the same heritage of how Google built out their cloud offering way before most people were even aware of this happening, which is kind of the natural fit. But also as Prometheus and Kubernetes keep being maintained for each other and with each other in mind, and you kind of retain this coupling. So if you look at Kubernetes, one of the people on SIG instrumentation for Kubernetes, or at Kubernetes SIG instrumentation, one of the tech leads, I think, Frederick Brunk, he's also part of Prometheus team. So you automatically have this coordination between the efforts. Kubernetes invested insane amounts of time and effort and brain sweat into making kube state metrics, which is hyper optimized to emit precisely the data at Kubernetes scale into Prometheus or in a Prometheus compatible format. So just by the history and by the fact that those are so tightly coupled, they remain so tightly coupled because nothing else comes even near in amount of just raw performance. Obviously, there is Prometheus can be replaced if you just have something which ingests these metrics directly and emits them to a different system or stores them differently. So you're not forced to use Prometheus, yet unless you have really, really, really humongous data sets, you can run Prometheus if you just want so, or if not, you would just use an agent and start emitting stuff into Thanos or Cortex, or maybe an operator.
Since you mentioned these two projects, I am also curious to know, when should developer, DevOps, or whoever you want to call them, they should consider putting their part of workload into CNCF, these projects, Cortex and Thanos. Also, if you can also explain what is the difference between these two projects.
So both of them at the core do long-term storage. And if your model of operating within your company does not match Prometheus Federation model very well, both of those are recommended, or you just want to have long-term storage. Historically, Thanos started scaling the storage layer horizontally with object storage, whereas Cortex started by scaling the index and the querying mechanism. So one was really easy to store lots and lots of data with, or cheap to store lots and lots of data with, whereas the other gave you super blazing fast performance. And that's the historic thing, or the historic initial optimization. Cortex took the object storage code from Thanos, and so with Cortex, as of today or as of some month ago, you now have a system which scales horizontally both the storage and the querying and also the ingesters. Whereas Thanos, you're still only scaling the storage horizontally. But obviously, same as Cortex took in the scaling code for storage, Thanos is working on taking in the querying and such scaling code from Cortex. Of course, those projects are super friendly and work together, sometimes experimenting in different directions, but always maintaining the synchronization of, hey, what are you going to do next? And always trying to make it reasonably easy for the others to reuse their code.
Richard, thank you so much for taking your time out to not only just talk about Grafana Labs and Prometheus, but actually to go deeper and explain the importance of observability monitoring and how there are so many things that are happening. Security is there. I think it's also important for to comply with a lot of code that you're using there. So thank you for taking time out there, and I look forward to talk to you again. Thank you.
No worries. Thanks for having me. See you.